Hello, David.
Hi, Ethan.
Yep. Thank you very much. And
Hi.
Hello.
Hello.
This is Tom. Can you hear me?
Yeah.
yes, I can hear you. Hello.
Hello.
Hello, everyone. I just wanted to make sure everybody's in order, everybody's logged in. Looks like you're in good hands. Davide, thank you for facilitating. Thanks, Professor Sakal. Welcome to the session. Thanks, Ifan. I'm just going to go through the rooms to make sure everything's in order. Okay.
Thank you, Pavan.
Enjoy your session. Thank you.
Shall we test showing the slides?
Yeah. Okay. So the chairs of this session are Ifan and Daniel Brissaud, right?
Yes.
And the speakers, the presenter of the presentations. Let's check if they are in the.
Yeah, I can see the first speaker is Marco Frank. Marco
Yeah.
Frank, yeah, you are here. So you might want to have share your screen and have a quick trial.
Okay.
Perfect. Yeah, we can see it.
Okay.
Perfect. Yeah, and yeah.
The second one is
Duarte, right?
Is he connected or?
No, he is not connected. It's not connected yet.
Let's check. Okay, John is presenting the.
Okay, John is presenting.
Yeah.
Okay. Yeah. So and he will. I'm sure he knows how to do it here.
Yeah.
Tomohiko, maybe Tomohiko, you can have a try here.
Yeah. Yes. I will.
So you are going to present the last paper, right?
The last one, yeah.
Yes, but jointly with John.
Yes. Okay. Great.
Yeah. He's informed of that.
Okay.
Yeah. Okay.
I'm now trying to share my screen. Share. This it. And
yes. Yes, I can see it now.
Okay. Looks good. Thank you. Thank you.
Perfect. Also, Mariam, let's present. Perfect.
Yes.
Is also Elizabeth. Yeah.
I think is another presenter is Yusuk, is right? So Yusuk, can you share your screen? Are you the presenter of the paper about knowledge sharing methods? Hello, Yusuk. Are you online? Can you hear our voice?
Okay. We have two missing.
Yeah, maybe he is not on the deck.
Elizabeth and Yusuk.
Yes. I think they just finished the keynote. Maybe they are in the break.
Hello, can you hear me?
Yeah, no,
Yes, we can hear you clearly. Yeah, so would you please have a try to share your screen?
Okay. Wait for a moment.
Hi, hello. Yeah, it's in the office.
Sorry, there are some trouble. I cannot share my screen. Okay, I'll try to change. I will try to change the browser. Wait for a moment.
Yeah.
Now I'll check out once.
Elizabeth, are you online? Hey, Elizabeth, can you hear us? If you face some issue, you can try just to refresh your browser. Maybe it works.
I'm not on my desk, so if there is any, please let me know.
Okay.
Hello, David, can you hear me?
Okay. Hi.
So I know this might be a little bit confusing. So the issue is that Elizabeth had a personal emergency. I'm one of the co-authors of that paper.
Okay.
So spontaneously decided to actually fill it for her.
Okay, thank you. Thank you. Can you try to share your screen?
Yes.
Okay, perfect. So it works. Yeah. Now we just miss Yusuke.
Yeah.
Guys, perhaps we can start with the first presentation, if that is okay, because
yeah, otherwise
we are going to have problem with timing.
Yes. Okay. So okay. Hello, Daniel's here.
Yes. Sorry, it was again difficult for me to connect. I don't know why.
All right. Hello, Daniel. How are you?
How are you, Ifan?
Not bad. Long time no see.
Yeah.
So yeah. So just because you are the primary chair of this session here, and we have just a quick try of the share screen. I think only one speaker have not tried. I think maybe we can start everyone now. Is that okay?
Okay, I think that we can start. We are a little bit late. I am sorry for that. We are in session 3, Design for Service. I will share with you, Ifan.
Yes.
Till Daniel Brissot, professor at the University of Grenoble, like this morning. And Ifan, I let you introduce yourself.
Hello, everyone. My name is Yifan Zhao. I'm the senior lecturer in data science at Columbia University. So I will co-chair this section with Daniel together.
Okay, thank you. I think we can start immediately with the first presentation. It will be made by Marco Franke, I let you share your screen, start your presentation, because I need you to have the first slide of your presentation to know where you come from.
Okay. Can you see my slides in full screen?
Yeah, yes, please. I let you introduce yourself from your university and start your presentation.
Okay, thanks. My name is Marco Franke. I'm a research scientist at BIBA. BIBA is a research institute in north of Germany, in Bremen, and it's located nearby the University of Bremen. Okay, the title of my paper is Interoperability Access to Heterogeneous Test Knowledge. And I will present today what test knowledge means from my perspective and how it is useful for the through-life engineering services scope. Okay, for this I will first present the motivation, show them the benefits to include the data. Then I will present the problem statement, why this not happened so far. Then I show my approach, present the solution principles, and make an evaluation, and finally give a summary and outlook. This is a common agenda for this kind of paper. In principle, the scope is related to the through-life engineering services. The TS service address the exchange of high-quality data. This data should be used to achieve the reliability or to achieve the solidity of an aircraft or another complex system. And for that reason, our high-quality data or high-quality information which we would to integrate into the through-life engineering service is test data or test knowledge. This test knowledge should be captured by the beginning of life of an aircraft, because there it is located as part of the development process, and later on this knowledge should be gathered and should be represented in an appropriate manner and exchanged to everybody who needs this kind of information. Test knowledge, especially test cases, contains a very sophisticated view of an aircraft or another system. It contains everything. It contains from the requirements, which describes how the system should behave. It describes how to stimulate the system to trigger specific states and reactions, and naturally also it defines very precisely how the system should react under specific stimuli. That means the stimuli, the same reaction, and the expected behavior all together in linkages or requirements are contained in test cases. And this is the primary source and very good knowledge source for the complete life cycle of an aircraft or train or car, especially for the maintenance and the knowledge search for root causes, failure root causes. I would like to show very briefly the benefit onto two use cases. The first one is the resolution of no fault found, and the second is the usage of the information exchange in heterogeneous test process for the development of a complex mechatronic system. I will now go to these both use cases very briefly, and afterwards I will go directly to the problem description, why it's not happened so far. In principle, I know fault found, I think you already know it, but I will just introduce it again. In principle, if you have an aircraft an airplane in operation, a failure is occurred, some error messages occur somewhere in some logging, then this aircraft goes to the maintenance, and during the maintenance, the root cause of this failure can be detected. And that means the root cause cannot be found. That means no specific maintenance activity can be derived. As a output of this, not finding the root cause is that a couple of standard operations will be done, some checks, and later on the aircraft goes back into the operation. This no fault found happens usually, as you can see in the numbers, which are old but already irrelevant. And as an outcome of this, in 2014, a paper presented the idea that you could use the test knowledge, the test cases, as an additional information source to increase the information density for the search of the root cause for the no fault found. That means you take an additional data source, these test cases, and extract the stimuli and the expected behavior of the aircraft, and to feed this into the search to localize the root cause of the failure for the node not found. This was presented in 2014 with a vision, with an idea. And now, today, I would like to present for this paper in principle the approach which could be used for this idea. The second potential use case is collaboration in heterogeneous test processes. As you already know, an aircraft is not developed by one company, it's developed by one OEM and a huge set of companies as part of the supply chain. That means in principle, the starting point is one requirement set, and afterwards, based on this requirement set, a lot of companies develop an aircraft. And each of them has to fulfill or have to execute a test process. In this test process, they check the requirements if their system behaves like expected. And if everything works fine, everybody could deliver his system, everything could be integrated, and the aircraft flies directly. In reality, the problem is that a couple of times it happens that a system supplier develops his system. He develops his test cases, implement test cases run, everything's passed, and he delivers his product to the next lower supplier. He takes the product, integrate it, and check it with his own test process. This is in principle has the same requirements, but use different languages, test systems, and so on. And what happens is often that the test case fails on the lower supplier side for the integrated product. This is a common case, and what happens then is that in principle the system is sent back to the higher supplier with the test case which failed, and then the higher supplier has to identify why his product or his product didn't work as expected from the perspective of the lower supplier. And in principle, it's the same requirements which have to be met, but in reality, it's the way of implementing this requirements inside the test cases which differs. And that means for them the stimuli is different, or the kind of way how to check the stimuli reaction and so on and so on. And this kind of difference have to be identified, and for this at the moment it has to be done with a huge effort because the test case languages and the test system equipment is different for each of the supplier, and that means the test case which is sent into the higher supplier is for him not familiar. He don't know the language, he don't know the setup, and he cannot just execute it on his own test bench. So it means he'd have to do a manually search, a manual investigation. What was his stimuli, what was his reaction, and so on. And for this, something like exchange of the applied stimuli as part of the test knowledge would be very important. Would be very simplify his investigation. In principle, I presented two use cases for sharing test knowledge among the product lifecycle. And now I would explain why it's not so simple to share this kind of knowledge. In principle, this stimuli and expected behavior is codified in test cases. That means each supplier and each OEM creates his test cases to check the right functionality for his system or for his test level. The problem is that there are a lot of different test case languages, and each test case language has a specific purpose for what is built. And at the end, it results in languages which differs in the typing, in the programming predicament, and also in the execution behavior. Some languages support real-time, some didn't support real-time behavior. And all these differences result in different test cases. Also in the cases, and if you make in principle the same signal, if you try to set the same signal to the same value as shown in the example, you get completely different test cases from the look and feel. And if you try to exchange this kind of test cases between the supplier, it's very hard to understand from the other side what did the other supplier, and how can I copy in principle his test case into my own language. That means, as if one of the main problem is also in the test cases, which checks exactly the same requirements, checks exactly the same on the semantics level, they have a complete different structure related to the test case languages, and also to the way how to stimulate the specific statement inside the language. This is one of the main problems why test cases are not interoperable, which you cannot just exchange as knowledge among the supply chain or among the lifecycle. The other problem is, this is the second statement, if we are lucky and we have the same test case language applied at two suppliers, unfortunately, the test cases will look also not similar because each supplier or each test system supplier adapt his test system with additional macros, additional libraries to support more and more or better comfort functions, and which also are used in the test cases. But at the end, if you take these two test cases, also in the case as the same language, it differs because they used additional or integrated additional capabilities for this specific test bench. Apart from this interpretation side, also the configuration differs between the test systems of the suppliers. That means the application of different consent files for setting thresholds or to map the specific signal mapping from the generic signal name, for example, left door 1, to specific signal name on the test bench, which has normally a port and an IP address or something, and a specific protocol. This kind of mapping also differs. That means to exchange test cases, you need to resolve both worlds, or means that you have to resolve the test case languages and to resolve the test specific triggers to enable an interoperable access to this kind of knowledge, to know afterwards which kind of stimuli was applied, which kind of checks was applied, what was tested in this time frame, to really know what happened in the test case without knowing or without the need to understand the test case language, without the need to understand the setup and the architecture of the test system. But this is important because what the user wants to need is just the information, what was the stimuli and not the surroundings, how it was executed. Based on these two problems, we created an approach. The approach has a vision. In principle, our vision is we would like to achieve the readability of test cases independent from the test case language and the test systems. And that means we want to propose a way to create interoperable test cases, or more precisely, the content of the test cases to represent this in an interoperable manner. And based on this interoperable representation, to support a search capability which can be executed by a common engineer, not by a skilled guy from the test case department or some information scientist. For that reason, we created an approach in which it has three steps. The first step, we translate a test case from a test case language into an intermediate representation. It's called SXML. It has been already research. It's already done by previous work, and it used generic SXML, which is just a state chart to represent a test case independent from its test case language. Based on the SXML representation, we try to focus on the semantics of the test case to identify which are the common statements for creating a stimuli, for creating a check, for creating timing dependencies. And for this, we define these statements. And based on this, we create a direct translation of this kind of information into a graph to enable a wide range of search capabilities, and also to use the very huge set of search capabilities already provided by a graph database. That means the approach foresees that we upload a test case, or that we upload test cases from different test case languages, first to SXML, and then into a graph that we have one point of interest, one central database to store all different test cases over all test campaigns, over all companies, so over the complete supply chain, to enable the search for similarity, to search for give me this similar pattern, and so on. And now we'll present for each of the main steps for the approach a detailed overview. If it's too much, just say it and I will skip these technical details. If not, I will explain it. The first approach is that I presented before that a test case language has a specific set on a structure, has a specific characteristics. For that reason, we created an approach. This is already it's an old approach, but it uses the legs and paths of each language to translate, in principle, a path tree, which is just a tree of the statements of the structure of test case, into a timeline. The structure of a test case differs among the languages, but at the end, what is the point of interest is that we have to know when each statement is triggered inside the test case, because this is how it is, how a test system sees execution of a test case. Because he has just to know, first I trigger signal 1, signal 2, signal 3, then I wait a couple of seconds, and finally I make a check if the system reaction is as expected. This kind of timeline we use to use as a common baseline for a direct translation then into the target format, which is SXML. And we use SXML and define on top some common test case specific statements or syntax elements to represent a test case in this SXML. It's called generic SXML and is also output of this research project. Okay, if we have this interoperable representation of a test case or of test cases from different languages, we created an upload to a database that we can have that we have one central storage to store all test cases. We choose a graph to make a very flexible search available, and in this we add a test case as one graph, and if we upload more than one test case, we have a couple of not connected graphs inside one database, and which we can jump in at each specific statement to start the search and make it very efficient to find any pattern which is contained in any location inside a test case. To define in principle what we're looking for is that we translated the structure of a test case, which is in principle the building blocks, also the test steps and the timeouts. This kind of structure we translated into the primitive structure of a database. For that reason, we define the corresponding tags and labels to do this. And in addition, we defined labels and variables for each specific statement which we identified based on SXML, which is addressed for the user on the right abstraction layer. For example, we created a state which described I want to set a signal to a specific value, just as one node, or I want to create a ramp, to ramp a signal to a specific value, also just as one state, or that's one node inside this database. In the original structure, a ramp would be would have a couple of states, but from the point of the semantic, it's just one statement, it's just a ramp, and we took this abstraction to make it very simple to add this kind of statements inside this database to make it searchable. If we have everything inside the database, the question is now how we can search for this in a way that a common user can look for this. Because normally what you would expect is, you see at the top right, that if you use a database, sorry?
It's already 20 minutes, Marco.
Sorry. Okay. Okay. I will. Can I speed up, or do I have to close?
You have to conclude, I think. Because...
Okay. Sorry. As a principle, we could a query language with use is based on patterns. You see on the examples. Is not to use the query language to make it feasible for everybody. We took an evaluation which we could estimate we could find for we could find patterns in test cases. The result is we could find the exact pattern. We could also find similar patterns, and that means we could find very similar structures, which allows summarization or find similar similarly for these different use cases. And the summary is, in principle, we can extract the knowledge of test cases in an interval way, store it, make it searchable, and in a way that each normal guy could search for this, define this pattern, and use it directly. The outlook is, in principle, we go forward, increase the catalog of supported statements, and create or define a complex search workflow in which you could iteratively increase the search query pattern to go deeper in the specific region you would like to search for. In the case of a no fault found, or to find the right stimuli for the right test case. Okay, this is in principle it. And yeah. Do you have questions? Sorry for too late.
We are running for more than 20 minutes, and now we have not really time to have discussion. Maybe just no. It's not possible. I must say to the other speakers that you have to be within 20 minutes, including questions. And here it's more than 20 minutes, and we have no time for questions. I am sorry about that.
Okay, sorry for my fault. Okay.
Could we go to the next presentation, please? You have to stop sharing the screen, please, Marco.
Okay, I will. Where was it? Okay.
And I would like to ask the second speaker to open his camera and to share his file after.
John, are you going to present your second paper?
Will you present the second paper, John?
There's some problem with the. I think you need to refresh the page.
Back to me.
Hello.
Hello, John.
Hi, can you hear me?
Yes, we can.
Okay, great. Shall I share my screen for the next paper?
Yes, please do, John, and you know the rules. I hope so. Thank you very much.
Okay. Can you see my screen?
Yes. Yes, John, please do.
Okay, I'll make a start then. So hello, everyone. Welcome to this presentation. So this piece of work was based on a PhD project. The person working on the PhD was called Duarte Rodriguez Polonia. It was a collaborative project between Cranfield and Babcock International. So the title of this presentation is A Multi-Objective Cost Availability and Time Optimization Model for Bidding Stages. So I'll go into explaining the context, the agenda for this. So firstly, I'd like to introduce the research background, then I will move on to the research objectives, then I'll introduce you to a model that we developed, and then I'll show you an example case study that we used to validate the model that's been developed. And then finally, I'll conclude and provide some future work suggestions. So in terms of the background, this project was particularly focusing on the bidding stage. So if we look at, and we particularly focused on availability-based contracts. So if you look at the life cycle, in the defense type context, the life cycle is often defined based on the phases called concept, assessment, demonstration, manufacture, in-service, and disposal. So in this project, we really focused on the bidding processes, whereby we wanted to understand the project size, the complexity, the customer requirements, the duration of the contracts. We wanted to understand the different cost drivers and also the availability drivers. So for us, the ultimate challenge was, how do we understand the attributes that really influence cost and availability so that we can start to manage those attributes better and improve the bidding process? So the kind of challenge we were dealing with was, in the bidding process, there isn't much time, and we need to become effective in the process of building the bid if I'm a solution provider. So we were particularly coming from the perspective of someone that's making a bid to a customer for a kind of availability-based solution. So that was the kind of context that we were working on. So one other thing that I'd like to just highlight here is that one of the challenges we identified in the bidding process was that there's limited data available when you're building your availability-based solutions, because each availability-based solution can be quite different, and in many cases the data across different projects for availability-based solutions hasn't been collected in detail. So that was the kind of context, that was the kind of challenge area that we were working in. So just some definitions in terms of the project and how we developed different terms. So investment is referring to the money that's committed. Optimization is really about finding the best possible solution to achieve the predefined targets. With system, we're referring to small, medium-sized, complex engineering system or equipment. With availability, we're particularly focusing on the operational availability of the system. And attributes are a set of elements that have an impact in the availability targets in contracting for availability. So CFA stands for contracting for availability. So the research objectives for us were listed in the slide. So firstly, we wanted to identify the different attributes that can have an impact on cost and availability targets in availability type contracts. We wanted to understand the relationships between these attributes so that when we're managing the cost or availability outcomes, we want to see how these attributes actually work together to influence those outcomes. We also looked at how can we measure the impact of these attributes so that we start to really build an association between the outcomes and the attributes. And lastly, we wanted to understand how can we actually optimize the investment to be made across the different attributes. And this was done in a way that we can achieve the different availability targets and cost targets that we have. So it's in a way setting the destination, the target, and then we're working backwards with apportioning the different levels of attributes that will contribute to achieving those targets. So in terms of the research elements, for us, the context and the target was really about contractual costs and the system availability level. In terms of levers, we were looking at the attributes that can impact the system availability. So we really broke down the range of attributes that can have an impact. Then we looked at the enabler, which was the budget. So by changing the level of the budget, we then need to work backwards to understand how those attributes will contribute to delivering the availability level that we're targeting, as well as the cost level that we're targeting. So that was really the key elements to this research. And we really focused on how can we optimize between the budget and these different attributes within a given project. So as part of this project, we focused on building this optimization process so that we can start to maybe trade off between different resources, different attributes. We can also start to trade off between the different levels of budgets that's available. So in terms of the model that we've built, there are various inputs. And firstly, we looked at the attributes. We tried to understand what are the different attributes. We also required an input around contract duration and the cost targets and the availability target. So from there, our optimization process produces outputs, including the optimal investment across the different attributes, the estimated total project costs, the estimated level of system availability, and the optimal contract duration. So it's really trying to illustrate early on or at different phases in the bidding process, what would these optimal outcomes look like? So this is just to give you an idea that we're really focusing on the context where there isn't much data. And we try to simplify the data input process. So the knowledge base that we built, so the modeling approach that we built relies on developing a knowledge base. So this knowledge base may contain information from various contracts. So for example, here you've got contracting for availability 1, 2, 3, 4. So this is just an example where we've got 4 different projects. And for those different projects, we're collating information such as the availability that's achieved, the contract duration, the unplanned maintenance, the planned maintenance, and system and engineering. So these are the different kinds of investments required in different attributes. So once we have this knowledge base, we can start to use that in our modeling process. So the modeling process is involving things like multiple regression and genetic algorithms. So we're using this because we want to learn from historical projects and associate it to our current project of interest. So we're doing this because in many cases we don't have the data that's required, and we're trying to use inferencing and developing the database to a substantial level, which will be sufficient for modeling purposes. So our initial database would be along the lines of the 4 contracts that I just showed you. And then we would develop a Monte Carlo-based simulation whereby we extend the database And once we've enhanced the database, we can then move on to apply multi-regression analysis. And this multi-regression analysis is firstly focusing on the availability function, where we're looking at what is the outcome in terms of availability of the asset. And secondly, what is the cost going to be for that asset's availability. So once we've done this analysis, we're still building our database, and then we apply the enhanced genetic algorithm. And this is where we're really using this to develop the optimized solutions. This is where we're really trying to offer the optimized contract duration, the optimized availability level, and the optimized cost level. So the interface that we developed requires a target to be defined initially. So the target could be based on the cost level and the availability target. So you may provide an input for the total cost and the system availability level. And this is just, in a way, a starting point. So from there, you also need to define your project duration. And that would be based on, in this example, based on years. And then we're really trying to start to define what the optimum would look like. So from these targets that we've defined, we can also start to go into different attributes. So these attributes, such as maintenance planning, packaging, obsolescence, personnel, health hazards, all these different things contribute towards the total cost. So what this toolkit is really trying to do now is understand the cost breakdown structure and then estimate the total contract costs. So we're really trying to now use historical projects, look at the costs that have been experienced across those different projects, and reflect that in the new project that we're working on. So from the example that we developed here, we can create optimal solutions. So in this process, we're really trying to trade off between the availability and the cost. And this chart is just an example from one of the case study projects that we applied this on. So here, what you can really start to evaluate is, you can see how the cost is changing, how it's evolving. At one point, the level of availability is significantly affected, even though you're pretty much spending the same level of costs. So it's really a toolkit that gives you an appreciation of how changing the different attribute levels can have an impact in terms of the total costs and the total availability outcomes. So if you're building your bids, you can really start to decide at what point do you want to prepare and submit your bid. So in this kind of context, you can see as there's a huge reduction in the availability when you from when you start this program, and then the per unit cost investment versus the availability that you're getting evolves as shown in this chart. So I guess what this is kind of highlighting is that sometimes spending more money can actually produce higher availability, but sometimes it actually doesn't produce higher availability. So we really need to think about how can we trade off these different options and how can we choose a suitable optimum point. So to conclude, there are still a lot of challenges at the bidding stage, particularly driven by the data that's available, the uncertainties, the risks that are present at that time in the life cycle. Inaccuracy of estimates is a major challenge. It's really significantly impactful. So it can have an impact in terms of a project being successful versus not being successful. So the more we can invest in improving predictability, the more we can really understand the kind of confidence in the estimates that we have, it will be beneficial in the bidding process. So what we focused on in this paper really was offering a new estimation approach at the bidding stage that relies on historical data, and it can infer from the historical data that you have. So it's an intuitive process, it's a systematic process, and it's really simplifying the inputs that are required in the bidding process. So we're trying to also come down to an attribute-based approach, whereby we're trying to illustrate how the different drivers of cost and availability can have an impact on the overall project. And we're also trying to optimize the cost, availability, resource type outcomes. So that's really what we've done in this project. In terms of future work, we'd also like to recommend a few areas. So firstly, we'd like to explore a more comprehensive range of attributes that affect cost and availability. We also want to look at extending the range of techniques that have been used for modeling. And we'd also like to look at a range of contractual options, apart from not only focusing on availability-based solutions. So with that, thank you very much, and I'll be happy to answer any questions.
Thank you very much, John. We have time for a couple of questions. We have 2 minutes for that. May I have one? Because if I understood well your methodology, you need to have the historical data for the different projects. And the question is, of course, what are these data reliable? What is the real cost? How has it been updated when something occurred?
Yes.
It all depends on this quality.
It does. It does depend on that. So the way we see it, obviously, is that the more projects we could have, the better. But in many cases, there aren't that many projects that are related, or they have a certain level of data in their system. So for us, we need some level of confidence in the data for each project. If the data isn't sufficiently usable, then we wouldn't include it in our portfolio of previous project examples. So that's a key thing here.
Okay. Other question? We have time for one additional question.
I guess I'm not sure if Steve Wilding's in the audience. We prepared this work with Steve. I'm not sure if Steve, you'd like to add anything?
John, Steve is not the speakers here.
Okay.
Attendees here, so he cannot have any voice input here, unfortunately.
Sorry then, that's fine. So yeah, I think for us, it was a very much industrial project, and it was very much. Oh, Steve's joining.
To follow on from what John said, it's not just the quality of the individual projects; it's the number of projects that give us refinement. One of the things, a typical example is the fact that we had to make a decision as to whether or not we trained individuals to maintain equipment, or we made the equipment smarter. So do you spend money on the equipment, or do you spend money on the training? And at which point do you actually gain benefit from one and stop gaining benefit from the other? So in a way, try and find a way of creating a value figure for each pound that you spend on training. So if you spend, I don't know, £100 on training, does it give you a 0.1 increase in availability? So you've got to establish that link first. And the same for equipment. If you spend, I don't know, £10,000 on the equipment, does it give you that same 0.1 increase in availability? So you've got to look at all of your attributes across the board. So it's your information that you supply to the individual, the training you supply to the individual, the support services, so the facilities that you supply. The hardest thing really was attributing the availability difference to the amount you spent in the first place. And obviously that would be refined the more projects that you got, to give you the fidelity of each of those.
Okay, thank you very much. I think that we have to move to the next presentation. Thank you, thank you, Steve, for this presentation.
Thank you. Thank you very much.
Could you stop sharing your screen?
Yeah.
Good. And now it's time for the third presentation.
Hello. As you might be able to tell, I'm not Elizabeth. Unfortunately, she had a personal emergency I filled in last second here. But I'll try to be one of the co-authors on the paper. So I'll try to ask questions that may arise as far as I can. But if you want to have really in-depth discussion, I would suggest you just contact Elizabeth directly after. Okay, let me start. Going to talk about digital fit instructions for further usage throughout the product lifecycle. This was done as part of a project called Cockpit 4.0. It was publicly funded. It involved the Brandenburg University of Technology, Rolls-Royce, as well as 3 Fraunhofer institutes in Sweden and Germany. The key aspects here were digital assembly, technology-enhanced learning, training and assistance, semantic product data, and work 4.0. So this is basically accounting for the fact that engine manufacturing a lot of manual hours involved. Or this human perspective is very important there. It's not that highly automated. To just give you some context, looking at is basically the kind of document to hand over the design data to the realm of manufacturing and assembly. So we have something that's called a fitting instructions, a certification document, basically from CAD files. The design engineer generates it. It defines the construction. It's usually available in that particular environment as a PDF file, just natural language. So you can actually tell there's different styles between different people that write those, which, you know, is nice if you read your favorite author for like a novel. It's not ideal in a manufacturing environment. Another big document here is assembly control record. Those are basically step-by-step descriptions, basically assembly manual. They're heavily used during the production phase. They're actually generated by the manufacturing engineer because what they involve is, on one hand, the fitting instruction information, plus included are additional tools as well as materials. So that's obviously like a huge difference there, and something that basically the design engineer has no visibility of whatsoever. The goals within the project framework were of fitting and assembly instructions, to use those beyond basically the design phase, and to kind of bridge the gap and kind of alleviate the bottleneck that this manual step had created. So the big 3 columns are digital or machine readable fitting instructions to be easily processed further down the line, intuitive and collaborative creation of digital instructions, assisted and in virtual reality, which accounts again for the manual aspect and was supposed to use for training efforts and some other simulations. And this was also supposed to be used to validate fitting and assembly instructions by 3D simulation. What was done was, can you see the slides?
You're not sharing.
Yeah.
Oh, actually, I apologize. Your screen. Yeah, I apologize for that. I got ahead of myself here. So I guess you didn't miss out on a lot of things. So this is like a quick overview. This is what those documents look like. One obviously like a draft. The other one is more like a step-by-step manual, including, things like glue, lubricants, things like that. Yeah, and those are the columns. So what we're doing for the first one is we decided it's important to develop a language model for fitting instruction and assembly control records. So to get beyond the free text that we basically faced before, what we identified was that this has to follow standard sentences and within simplified technical English, because that was not the case so far. Then we decided we need a new assisted process to generate those documents. Once again, to get away from this, everyone can just write whatever they feel like is appropriate. And we wanted to integrate virtual reality for intuitive interaction and creation of fitting and assembly tasks. So that way you can actually, in a very natural way, record certain steps that you as the manual assembler would actually take later in the process. And then also for the validation aspect, we wanted to support automatic collision-free path planning to then qualify those instructions. Because what sometimes happens is if you have people work on this, obviously there's glitches and errors. So sometimes things are just cannot be assembled in a way that is suggested by a document. And in order to be machine readable, where you don't have this human that looks at it to catch the error, you kind of need to get rid of those. So ergonomics was a huge aspect of that as well. So what we did is we wanted to understand the usage context and the document content. So what we employed here was interviews and user stories. We basically sat down with 5 design engineers and 4 manufacturing engineers and conducted semi-structured interviews. They were mostly related to the human-computer interaction. What we did is qualitative content analysis. Based on that, extracted 5 core issues with positive or negative valence. So it means, like we have here as an example, it's important to use old fitting instructions as an inspiration, or something negative like never experience components physically can lead to errors. Based on this, we derived 19 user stories as requirements for our demonstrators that we were supposed to create and process. And can you see my slides actually?
We can.
Okay, perfect. Thanks for the quick feedback there. Yeah, so the concept for the entire demonstrator is basically based on certain aspect, like what we call FILMS, the formal instruction language model, which is basically generic data structure for every kind of fitting instruction, but in the realm of standardized technical English, and it follows a certain structure. But we can basically, theoretically, we could adapt this for any kind of manufacturing / assembly process model. The assistance system was supposed to have user interface to generate fitting instructions in that model language, as well as also connect to virtual reality for intuitive handling and visualization of the processes or the instructions that someone generated. Yeah, Exchange server easily readable format, and another aspect was path planning for the automated simulation of collision-free paths. So we actually had quite a lot of goals there with that. What happened first was a document analysis, because we had a relatively large sample size. We analyzed 86 fitting instructions and 58 assembly control records. We extracted het words and word class. So as you can see on the right, we looked at word stems, all of that stuff. Compared that to the standardized technical English standard, and categorized into 6 classes or 6 category or modules, which was a little bit inspired by natural language grammar for obvious reasons. So we defined something called an operation, target, reference to a specification, which was kind of an outlier there, but it happens a lot where if you give humans the opportunity to add notes and specific references in natural text, there's a very individual to how people that was kind of a challenge to standardize this. Then a resource like a tool, or as I said, like a lubricant or some kind of material that's used. AIM is like the operation, and a relations. For example, if you have something like screw part A and part B with 3 screws, this could happen at the same time, or it could happen in a particular order. What we did then with that is we went and took a few people. We actually used some interns that worked on some of our projects, and had them actually look at the natural language documents, and then have them kind of try to reliability was an R of 0.8, which means that there was 80% fit actually, and only 20% where they deviated. So that's a pretty good goal actually. We started off with something around 0.5, which obviously at that point. This is actually what we ended up with at the assistance system. The user can import the product structure based on a JT import, PDM, they in this little window, the JT model viewer, select up, include in their fitting instruction. They have a preview for their fitting instruction. They have a process model view here, which some people prefer, especially if you do a lot of different instructions that are very similar, like things like third screw from the fourth screw from the right. You might actually just want to grab those modules and kind of like multiply them and just adapt them to your whichever position you are, left, right, something like that. Then the central part is actually the instruction builder, where you can combine different modules on one hand, so you can actually kind of create those little components and then form an entire fitting instruction out of it. But you can also actually just add free text. This was based on the interviews, because this was supposed to be a low impact kind of tool, so we wanted to make people's life and not necessarily just harass them with just another tool, because people usually love being harassed with new tools. No, but so in this case, you can actually just work as you used to, but you have a check for standardized technical English. So usually, if you use some kind of vocabulary or some kind of structure that's not recognized, it will throw you an error, and you can adapt that. And here on the right, as you can see, is the language modules, where you can actually grab those different components to create your fitting instruction. Another thing that this here is actually that this kind of, I think, makes it quite nice to have the VR option, is you can literally assemble something in virtual reality, which will then be recorded and kind of serve as your assembly order. So you can kind of use that to support your process here that you see on the other side of the process model, to kind of show comes before another operation, because depending on the complexity of the module or the assembly that you're working on, it's actually kind of hard to keep track on this just based on the PDM structure here, especially if you have very obscure file names or feature names. So it's actually fairly nice to have this as a more realistic kind of representation. Oh, give me a second here. Oh, okay. So yeah, and we can use this for animation. So as I said, the collision-free path planning. There's some additional work on this done. Our partner institute has this thing. It's called the Industrial Path Solution. So this is actually an engine that can be used for collision-free path planning. As you can see, it has some ergonomic features to it. We can digital definition in the assembly bills of materials or bill of processes maintained in Team Center. This can be used for training to support the creation of training content in different departments of the company. This actually has also been heavily utilized, and it's also supported by the fact that Rolls-Royce is very interested in applying or utilizing AR for to support their manual, not only training but also people that are actually working in the manufacturing line. Yeah, and this can actually be used for visualization and operations for simulation in VR, or using natural language sentences for step-by-step instructions with augmented reality on the shop floor. So you can actually also use, you kind of flip it around and generate sentences from something that you created within VR. So you could actually have someone tell you what to do based on what you did in an AR or VR environment. This is certainly, there's still some work to do, but it's so far very promising, and it's very nice to bridge this gap between design engineering and manufacturing and assembly there. Yeah, so that would be it. There you can also see Elizabeth. All right.
Thank you very much for your presentation. Quite interesting. Yeah.
Thank you.
Maybe I'll start by a question, because I didn't understand very well if this system was implemented in some industrial case. What are the conclusions? And what are the performance that has been improved by your system?
So I think what they had is they had a good amount of quality escapes, basically due to fitting instructions that were phrased very, very differently. And I think there were ambiguities in it, and this was actually their main problem. And it's surprising how much of a problem it actually was. And you know how it is in 99% of cases, and someone that's very, very experienced will catch it, but every so often it doesn't happen. So this definitely solved this issue. And then also it made it more feasible to use AR and VR for training, because you don't have to generate separate processes or assembly, you know, what's it called, assembly steps, just to use or power a VR scenario, basically.
Okay, but it's a little bit paradoxical, because when I am an engineer and that I use annotation and instruction that I want to put on my screen, it's a free format for me, and you want me to structure in order to collect this information and to reuse it. Is it really accepted by engineers?
I think it's accepted fairly well. There were obviously some concerns in the beginning. I think what really pushed us over the edge there is the option to just use free text and just have a standard technical English check or structure check. They are already supposed to actually follow a lot of guidelines, so they're already kind of dealing with being reined in quite a bit, but sometimes the rules and regulations aren't entirely clear. So I think there are some reservations on one hand, but then there's also, I think, people that see the potential, and at least the rules are clear now, basically. I think that's definitely something that they all appreciated.
Okay, it's very promising. Is there any question from the audience? No, it's not so easy, and it's not easy for me because I cannot see anything. Okay, I think that I have to thank you very much for your presentation.
Well, thank you.
Discussion. And we can go to the next one. Maybe if maybe you could.
Yeah. Okay.
Please.
Okay, Daniel. So I think the next presenter, Marian, she has an emergency meeting now, and she said that she will come back to the end of section here. So could we move to the next one here? Yusuk, can you present your paper here? Yusuk, are you online?
me?
Yes, yes, we can hear you. Yeah. Can you present your paper, please? Thank you.
Okay, sure. Can you see my screen?
Yes. Perfect.
Okay. My name is use case.
Yes, so can you try to complete in 15 minutes here, then we can have 5 minutes question and answer section. Thank you.
Okay. Wait a moment. My name is Yusuke Tsutsui. I'm in Tokyo Metropolitan University, and I'm a doctoral course student. The presentation title is Knowledge Sharing Method to Equalize the Interpersonal Service Quality. Okay. Interpersonal service plays an important role in society to enhance people's quality of life, and the needs for them has increased. So, it is required to realize high quality of interpersonal services. On the other hand, the quality of interpersonal services depends on the service provider's knowledge learned through their experience and education and so on. In nursing sector, for example, the nurse provides a service to the elderly person. In nursing care sector, not only the physical, but also the mental health of the elderly is improved by appropriate treatment according to the condition and behavior of them. The quality of service depends on the knowledge of each nurse, such as how to understand the elderly, how to decide service content in service delivery, and so on. In this way, the quality of interpersonal services depends on the service provider's knowledge. These characteristics come to the barrier to enhance service quality efficiently. In responding to this, the importance of knowledge sharing among skilled service providers has been drawing attention as a means to enhance the quality of services. By sharing the knowledge of skilled providers, unskilled providers can increase their knowledge and enhance the service quality. In knowledge management area, there are two types of knowledge, that is, explicit knowledge and tacit knowledge. Explicit knowledge can be expressed in formal and systematic language and shared in the form of data, scientific formula, specification, and so on. On the other hand, tacit knowledge is highly personal and hard to formalize. Subjective insights, intuitions, and hunches fall into this category of knowledge. Nonaga claims that in order to improve organization, it is important to formalize and share tacit knowledge in organization. Therefore, to enhance interpersonal service quality, it is important to formalize the tacit knowledge of skilled providers into explicit knowledge. In existing studies, there are some methods to support to teach and identify the tacit knowledge of skilled service providers. For example, in nursing service area, active learning is recommended for education. In education in school area, the tacit knowledge of the teacher is extracted by interviews with recordings of the class. However, it is still difficult to formalize the tacit knowledge of skilled service providers and share it organizationally. Therefore, this study aims to provide a method to share tacit knowledge among providers in interpersonal service. The proposed method will formalize tacit knowledge of skills service provider with visible symbol that is easy to understand. In other words, this method supports knowledge visualization. This method potentially increases the reusability of tacit knowledge and support to share it organizationally. This slide and this figure shows the overview of proposed method. This method includes 2 steps. Step number 1, the tacit knowledge that the service provider applying front stage is extracted. In this step, the analysts conduct observation and interview to the provider. In step number 2, the tacit knowledge is formalized using the visualization tool. I'll explain in detail step by step. Step number 1 includes 2 sub-steps as explained in previous slide, that are observation and interviews to the provider. On the observation, an analyst observes interaction between provider and receiver. Through this observation, the analyst obtains the data mainly related to the action. The obtained data is described in a red area on the tool, this area. The next, the analyst conducts an interview to service provider. This interview helps the analyst to extract tacit knowledge that cannot extract only in observation, such as service provider thinking, emotion, and so on. In this context, thinking means the element of decision-making in the front stage of service. The emotions mean the subjective aspects of consciousness, such as present and unpresent. In step number 2, the analyst formalizes the tacit knowledge using visualization tool shown in this slide. The data obtained in the interview is, observation is described in red area shown in this slide. For example, the action of the provider and receiver is described in this node, and the next action is described as action number 2, and these are linked to this line. And the interaction state is described in this way. The data obtained in the interview is described in green area. Green area includes 2 elements, mental state and action. Action option. Action option means the action candidate that is not chosen by the actor, provider and receiver. And mental state includes the thought and feeling and so on. Although the analyst conducts the interview only to the service provider in step number 1, analysts can get this area of data through the interview. The reason is the provider assumes or estimates these elements on his or her mind. Yes. In this way, the tacit knowledge is visualized and transformed to explicit knowledge. To verify the effectiveness of proposal method, we applied it to robot therapy service. Robot therapy is a new therapy method that uses robots as substitutes for animal-assisted therapy. Therapy robot is an interactive robot for therapeutic psychological enrichment by stimulating the mind. Therapy robot is shown in the figure and that is called paro. The effect of this service is therapeutic psychological enrichment to the elderly. However, this robot therapy service has some challenges. One of the challenges is the effectiveness of therapy is depending on caregiver knowledge. These characteristics deserve to enhance the service quality. In order to test the capability of the method to visualize the tacit knowledge, we conducted 10 minutes therapy 2 times provided by caregiver A and B. Caregiver A is well-skilled provider rather than caregiver B. And we applied the method to visualize tacit knowledge of them. And after that, we compare the result of visualization of caregiver A and caregiver B. If the proposed method is sufficiently descriptive, it should be able to visualize the differences in tacit knowledge of the caregivers. This figure shows the results of the application to caregiver A. This area shows the state of the beginning of the service, and this area shows the end of the service state. This red area, we focus on this red area. This part shows the provider's decision. To summarize this result, caregiver A demonstrates how to treat paro by stroking paro because she wanted to show its safety. This is, we can see that state in this area. The caregiver A first taking a sheet with paro, and after that, she put paro on her own lap and stroking him in order to show how to use it. And this treatment is because of his mental state. She wanted to show its safety to the care receiver. After this, user came to take an interest in paro and looked relaxed. This state is we can see in this area. At first, receiver has low interest in paro, but after seeing the caregiver treatment, she comes to take an interest in paro and feel relaxed. This figure shows the result of application to caregiver B. Focusing on the service introduction, caregiver only say, "This is paro." This is paro, like this. Just after that, she handed over the paro to the receiver. This action is derived her thoughts, such as paro is used by 100 over as soon. However, we can see the low interest of the receiver referring to this red area. Although paro is passed to the receiver, she keeps listening and keep slight response to paro. This result can be summarized like that. In introduction, she just explained what paro is, because she thought paro is used by 100 over as soon. This caused, as a result, user keeps slight response to paro during the whole of the service. we compare the both results. Comparing the both results, we can see the difference of the tacit knowledge of caregiver A and caregiver B. Especially, I explained about introduction of the service. So the proposal method can visualize the different tacit knowledge between skilled provider and beginner provider. Let me summarize the main point of my presentation. This study proposed a knowledge sharing method. This method has capability to visualize the tacit knowledge of skilled service providers applied in interpersonal service delivery. The result is tested in therapy robot service. Proposed method has potential to support organizational knowledge sharing and contribute to enhance the quality of the interpersonal service quality. However, the visualization process takes a lot of time because of manually description. So, the software tool to describe tacit knowledge semi-automatically will be deployed in future work. That's all. Thank you for attention to my presentation.
Thank you very much, Yusuf. Very interesting topic here. So maybe I can start a quick question here. So we have two persons here. One is service provider. One is a receiver. So who do is a third party people to do the observation and the interview? Is that right?
Yeah.
Okay. So when you collect for example, the emotion here, you talk about the emotion here, pleasant or unpleasant here. Is that say the output from pleasant here, you consider this is a successful one, or unpleasant one is not a successful one? Is that correct?
Yeah.
Okay. So yeah, because when I read your visualization framework here, I didn't see the input from the emotion here, but I can do this input from emotion from your applications here. So if you go to your slide 8 here, and it is slide number 8. Number 8. Yeah, previous slide here. Yeah, so here, I'm wondering, because you're talking about actions, thinkings, and emotion here. So there's no input from emotions in here, in visualizations from this framework, right?
In application result?
Yeah, I mean, here, should we mention the emotion here?
Yeah, sorry, emotion equal to the feeling.
Yes, I mean, so I thought emotion should be visualized as well.
Yeah. Thank you.
Yeah.
In current research, our research, we cannot separate feeling and emotion. So in future work, we have to describe emotion in good way.
Thank you very much. Okay, is there any other questions? If there's no further question here, so shall we move to the next presenter here? Yusuke, can you stop your screen sharing, please? Thank you very much.
Okay.
And Tomohiko, can you start your presentation, please?
Yes, I try to share my screen. One moment. One moment. Something is wrong. strange. One moment, I'm trying to.
No problem.
I will give one more try to share my screen mode. Yeah.
Yeah, perfect.
Yeah, good.
Yeah. Yes, please start.
Thank you. This is Tom Saka from Linköping University in Sweden. 4 of us, including myself, John, Andreas, Danielle, have been working on writing a CRP keynote paper about PSS design. So we are working together to review different challenges and different solutions for PSS design. PSS stands for Product Service System, which consists of physical products and human service activities. So this presentation will present 2 major challenges for industrial PSS design. According to literature, PSS has mainly 3 different properties: open process systems, business model, and social construct, each of which presents different characteristics. For example, the property open process systems means different characteristics. For example, human activities, heterogeneity, uncertainty, etc. And then those characteristics have different implications for PSS design. From the first open process system property, we see that designers are expected to apply systems thinking, integrate the product and service views, and analyze behavior as a system, and consider uncertainty. So this presentation talks about 2 different challenges that originate from these implications on PSS design. One is concerning systems integration, and the other is uncertainty management. This picture is taken from a sort of the classic paper that I, together with Yoshiki, wrote in 2007. This aims to describe sort of operations in designing product service systems based on sort of theoretical reasoning for what will happen in product service system designing. So basically this picture tries to capture different design parameters, one from product area and the other from service area. And PSS design can exploit the full potential only when these 2 different areas collaborate with each other. And I continue to work on implementing different PSS design methods together with manufacturing companies working on complex products and also providing different kinds of services. And then I got an opportunity to implement one PSS design method in a manufacturing company based in Sweden. And what we found from a 3-year project together with a company is one of the real main challenges in practice, in implementing PSS design in practice, is kind of organizational challenge. This picture is, I believe, quite familiar to most of you, that depicts the problem that occurred, especially in the 1970s, 80s, describing the problem between the design department and manufacturing department in one manufacturing company. But this problem was addressed by implementing sort of design for manufacturing method and sort of design related tools for that. But we saw this kind of problem on different contexts when we aimed to implement a PSS design method. That is the sort of division between the product development and service development within one PSS provider. Because this entire organization shares product design and service delivery lead time, and also obviously shares the economy. So this kind of division presents a problematic situation. Typically, product design team tended to stick to an existing solution when it comes to physical function, structure, characteristics, etc., without considering service aspects and also service designing activity. And as a solution, we helped this company to implement a PSS design method in their standard design procedure. Because this is very powerful, because every design project in this company must follow this standard design procedure. And after this project, the company sort of created a new function that sort of oversees the coordination and collaboration between product part and service part, and one specific manager was assigned to that function. Without this kind of solution implemented in a PSS provider, we or those companies continue to face different challenges in PSS design. And we realized that that kind of challenging situation can be well explained by borrowing the concept called design fixation. It is defined as this, which was basically found through experimental designs by Janssen Smith. And most of the research about design fixation has been performed to deal with the design activities in the micro level, meaning that individual designers' activities. But we realized that this concept is really applicable to a higher level, which is an organizational level or even institutional level. One clarification must be made here to distinguish between design fixation and design limitation, because there are situations for designers where designers can't do basically anything to overcome certain situations that we call design limitation. So the distinction between the fixation and limitation is sort of explained, represented by a similar figure that I showed you earlier today. On the left-hand side, there is a situation that we can call design limitation, because there is no means to address the sort of one of the design parameters. And in the middle, you see a phenomena that we can call design fixation, because there is a means, but the means is not really used. And on the right-hand side, you see the situation where design fixation is overcome. So far, I have talked about the design fixation in terms of the concepts that are used and developed over design process. But design fixation is observed also when it comes to the knowledge that is owned and used by designers. We actually, through a systematic literature review, we found there is quite a substantial difference between how the knowledge is used in engineering design and in marketing, each of which basically corresponds to product development and service development. And in order to exploit the full potential of PSS design, those two different professionals need to collaborate with each other. However, as I mentioned, knowledge of these two groups of professionals are sort of fixated. So this poses quite a big challenge. When it comes to sort of business orientation, this is one of the 7 themes that we identified that shows quite a big difference between the 2 groups of professionals. Business orientation is usually understood in engineering design as a sort of operational issue, but on the other hand, in the marketing, people look at a strategic level. So based on these difference, we can say that in order to support PSS design effectively, there must be some sort of collaboration to join different perspectives for business orientation. And when it comes to research about this, we can ask this kind of research question. One more theme out of the 7, I can show the requirements. The concept requirement is also quite differently addressed and understood. As you see here, functional versus more of customers' expression, unrecognized or recognized customer needs. And in order to perform successful PSS designing, we must combine these 2 sort of bodies of knowledge. And when it comes to research, we can ask this kind of question. So far, I have talked about one of the 2 main challenges that we observe when it comes to PSS design. That was systems integration on an organizational setting that is very much related to fixation. Now, one of the co-authors, John, will take over the presentation. I hope, John, you can take over.
Hi, can you hear me?
Yes, I can hear.
Great. Yeah, I'm here, Tom. Would you like to, move forward, please, with the slides? Sorry, Tom, could you continue with the slides?
Which number do you see? Which page do you see? 10?
At the moment, it's design, operations, and PSS design.
Oh, that's not what I see in my screen.
Daniel, I think you're muted.
Then, John, can you open the PowerPoint that you have in your computer?
Yeah, one moment. I'll do that.
Because I can see the slides of Tom that are not exactly the same as yours, John, please.
I can refresh, maybe.
Yes, the day was too long, John. Yeah.
I'll refresh. I'll be one moment. Okay, I'm back. Can you hear me?
Yes, I hear you, John.
Yes.
Okay, great. I have the slides. Okay, I'm ready to I'll share my screen. Just make it full screen.
Yes, we can see it now.
Okay, I've just made it full screen.
Great.
So hopefully you can see it now. Good. Thanks, Tom. to continue the presentation, a second area which we feel needs attention in kind of design environment is looking at uncertainty. So for us, the way we define uncertainty is it's about the missing information, and it's also about the difference between the information required versus what you already have. So that gap really can cause a system to behave in an unknown manner, or it may affect difficulties with understanding how the future outcomes may pan out. So if we look at, for example, across the product service systems spectrum of business models, from product-oriented to result-oriented, the level of uncertainty can increase. And the reason this can increase is for a number of reasons, whereby early on we may not have enough information. There might also be a lack of communication across the supply chain. And it might be that it's too difficult to have any information about the future because you haven't necessarily got the experience in delivering such types of contracts or support solutions. So in design, we really need to think about how we can introduce modularity or flexibility to deal with uncertainty, and to really think about this across the life cycle, because the types of uncertainties that you face can change across different phases of the life cycle. Even within a given phase of the life cycle, the uncertainties will be dynamic, and they'll change in terms of the amount of influence they have on key targets of your project. So with that, uncertainties, particularly with things like availability contracts or capability-based contracts, the need to make decisions is becoming much earlier than the traditional approaches. So what this means is that you have lack of information, and often the timeliness of its availability isn't at a good level. So that really affects the level of uncertainty you have. And the other thing to really think about is that if you don't have a good take on the level of uncertainty and its influence, it will definitely affect your bid or the project costs that you're involved in. So there are some key questions that are coming out that we need to think about increasingly. So one is really to understand the different types of uncertainties that are relevant, and also to really think about how these uncertainties will change over time, because some uncertainties may not be relevant in the future, and some of them may be even increasingly influential on your projects. So we really need to understand how the outputs of a project, the key targets that you may have, will be affected from the uncertainties. And we really need to start to understand the role of uncertainty from a design perspective, because we can have a huge impact with the different kind of methodologies you apply in design to manage the uncertainties. So if we look at the different sources of uncertainty, in literature, there's two main kind of categories that have been referred to. So one is around aleatory, and the other is called epistemic. So with aleatory, what is referred to is that these are very much environmental, they're stochastic, irreducible, they're very much random. So you could think of things like environmental impacts like earthquakes or various environmental conditions could be aleatory in nature. The second category is epistemic, which is really referring to the lack of knowledge that we may have, and it could be reducible. So here, the important thing is that maybe if you do more experiments or you analyze historical projects and you collect data, that could really help to influence your level of knowledge. So when you're considering these different types of sources, you really need to go into detail. Now, on the right-hand side, what I've included there is really talking about different types of data. So really, to manage epistemic type uncertainty, you need to consider multiple different aspects. So firstly, it could be things like the reliability of the data you have. It could be about accessibility. It could also be about the completeness of the data. So all these different aspects have a huge impact in terms of the level of uncertainty you have. So if I'm in the design phase and I start to really evaluate the different types of data that I have, then I can really start to build a measure of confidence with the different models or predictions that I'm making. So in that kind of context, understanding the level of uncertainty can also contribute to developing your uncertainty management strategy. So if you realize that you have issues with the usability of the data, for example, then if this is something originating from the supply chain, you may go back to them and request further data. So it really is important to understand the sources of uncertainty. Now, if we look at an example related to industrial product service systems, so IPS2, so there are a whole range of uncertainties that can be faced. So if I'm looking at, for example, flying planes, and I'm interested in the availability of the plane, so in that kind of context, there's uncertainties around the operating environment, there's uncertainties around the reliability of the equipment. There's also uncertainties originating from people. So it could be things like the maintainer, how they're operating. It could be about whether people have been trained at a suitable level. It could be about things like skill loss or labor availability. So all these different aspects really have a huge impact on how successful the industrial product service system will be. So in this kind of context, we also need to think about how all these different uncertainties in an aggregated manner can have a bigger impact in a way on the system level outcomes. So for me, this is also a really important aspect, a huge challenge that we need to consider when we're delivering in product service systems. So with that, I'll stop there. Are there any questions? I'm sure Tom and I would like to answer them.
Thank you, John. Thank you, Tom. Any questions until now? John, I got one quick question here. Say, when you quantify the uncertainty here, my question is how you can evaluate it, your uncertainty here. How you can make sure your uncertainty evaluation is accurate.
Yeah. So one question is around how do you evaluate the uncertainty? So for that, it really depends on whether you've got historical data that's quantitatively measurable. So sometimes you've got experimental data, sometimes you don't, and you're using very much qualitative information from experts. Now, the common approach in industry, what we've seen is to apply Monte Carlo types approaches, whereby you use typically a 3-point estimate. So that means you have your minimum, maximum, and most likely figures. In terms of validating your results with uncertainty, I think what we've done often in the past is to build your estimates and then look at the results afterwards in terms of what actually panned out. So we've really looked at that kind of approach, but sometimes that isn't available, and we've had to go back to qualitative-based validation. So looking at feedback from experts and collating their feedback in terms of what should the uncertainty range look like, and should we be adapting that based on their opinions.
Thank you, John. Is there any other questions?